Okay, so you guys, this is where it kind of starts to get hard. This lesson 90 is one of the hardest ones in the book, so do take great notes today. So let's see if you can fill in, no, seriously, see if you can fill in these tangent formulas. Okay, and then the tangent formula you could work out, you could plug in theta plus theta, add these together, that's 2 tangent theta. And in the bottom, if you have a theta and a theta right here, the same thing, you have 1 minus tangent squared theta. So I might not memorize this one, I might just plug it into this one, okay? All right, then we have the half angles, which we're going to derive momentarily, but until then, I just want you to fill this in. So the sine theta over 2 is plus or minus the square root of 1 minus cosine theta over 2. And the cosine theta over 2 is plus or minus the square root of 1 plus cosine theta over 2. So the sine one is minus, and the cosine one is plus. And the tangent is plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. So we are going to derive the half angle formula. All right, and it will ask you to do this on your homework, so I would take good notes, and I would probably look at my notes while I was doing these problems, okay? Because it will say, how do you do this, and then you'll need to verify it. Yeah, Anna? Yes, it is likely. All right, so what I want to do is I want to replace theta over 2 with a. So I'm going to make it a little bit easier, and instead of that theta over 2, I'm just going to say that this is equal to sine of a. Which means then, if I were to solve right here, that 2a is equal to theta when I replace it. So then what I want to do is look up at my formulas, and I want to find one of the formulas that only has sine in it, because I want to have just sine left at the end. So if I look at this sine formula here, or this guy, I want just sine left. The only formula that has only sine in it is this one right here, okay? So I'm going to replace the theta with an a, and I'm going to write it as cosine 2a. So I'm just repeating this formula right here, okay? I'm going to repeat this formula, and I'm going to put cosine of 2a is equal to 1 minus 2 sine squared a. All right, so the reason I picked this formula is because it has sine in it, and I want to get down to just sine of a. Because if I get down to just sine a, that's really just sine theta over 2, because I replaced the a with theta over 2. So the next step is to isolate this sine. Okay, so that means I'm first going to subtract 1 from both sides. So I have cosine 2a minus 1 equals negative 2 sine squared a. And the next step would be to divide by negative 2 on both sides. Okay, and because I'm dividing by a negative, I'm going to switch the order around, and I'm going to divide the negative out. So like if I'm dividing by a negative here, it's going to make this a positive 1, and I'm dividing by a negative here, it's going to become a minus cosine 2a all over a positive 2. So I'm switching all the signs so that negative 2 becomes a positive 2 in the bottom. And I'm also switching the order so it looks more like the formula that we're trying to get. Okay. And now on this side I have sine squared a. So now I need to isolate sine. And I would isolate sine by taking the square root of both sides. So this undoes the square. I'm left with sine a. And over here, anytime you take the square root, you want to remember plus or minus. And then at the very end, we remember that we set A equal to theta over 2. So I'm going to replace my A right here with theta over 2, because that's what it's equal to, and replace this A with a theta over 2. Now I get the actual formula, which is 1 minus. So this 2 cancels with this 2 in the denominator, so I just have 1 minus cosine theta over 2. And over here, I now have the half angle, the theta over 2, the formula that we wanted. What's the point of the plus minus? You have to look at whatever angle it is and decide if it's positive or negative based on what quadrant it's in. You would just graph it from 0 to 360 and then know if you're doing sine and if that sine is positive or negative or cosine is positive or negative, okay? Okay, this one is very similar, cosine of theta over 2. So we're going to start the same way, where off to the side here, theta over 2 is going to be equal to A. So this is going to be the same thing as just cosine A. So now I want a formula that just has cosine in it. So before I wanted one that had just sine in it, because I was doing a sine of theta over 2. Now I want a formula that just has cosine in it. So if you look back at your double angle formulas, this one right here is the only one that just has cosine in it. Okay, so I'm going to rewrite that, only instead of theta, I'm going to use 2a. I'm just going to copy the formula down, cosine 2a. So I have cosine 2a equals 2 cosine squared a minus 1. And now I'm going to isolate cosine. So just like we isolated sine, now I want to isolate cosine because I'm solving for this cosine theta over 2 thing. So again, I'm isolating here, which means I'm going to add 1 first to the other side. And then I'm going to divide by 2 on both sides. And then I'm going to do what? Yep, just square root it. I want cosine by itself, so I'm going to square root it. And anytime you square root, it's always plus or minus. And I'm going to switch the order of this because you can add in either order, and just so the formula is the same as what we wrote down. So I'm going to do 1 plus cosine 2a. It's the same thing over 2. And over here I have just cosine a. And then my last step is to go back and replace a with theta over 2, because we're trying to do the half angle, and we just said at the beginning that a is equal to, so a little cross off here, theta over 2, and we plug in theta over 2. So now I have plus or minus the square root of, and now this 2 here, these cancel out, and that's how we get 1 plus cosine theta over 2 equals cosine of theta over 2. So when you're doing the sine formula, you start with the double angle for cosine. And when you're doing the cosine formula, you start with the double angle for cosine. The only thing is, for this one I want to get the sine, so I use the sine formula. And for this one I want to get the cosine, so I use the one that has cosine in it only. Okay? Now we got to do the tangent one. Derive the tangent one. So for the tangent one, this is the same thing as just saying sine of theta over 2 over cosine of theta over 2. So it's sine over cosine. So what we're going to do is just take our formulas that we just did. So if you look in your notes, or if you look at what we just did, sine of theta over 2 is equal to plus or minus the square root of, and sine's always the minus 1, divided by, now I'm going to do the cosine formula that we just wrote in our notes, and cosine's the plus 1, And we can simplify this a little bit. Since they're both divided by 2, you can technically multiply by root 2 over root 2, or you can just cross them both off since they're both being divided by 2 like that. And if I do a positive negative divided by a positive negative, that still gives me a positive negative. But I'm going to go ahead and write it like this. One step at a time, I guess. So I cross the 2's off. I have that. And this is the same thing as one big square root. If you're square rooting the top and you're square rooting the bottom, then I can just do it as one big square root. And that's the formula for tangent. So when you derive the one for tangent, start with your previous cosine 1 and sine 1. Okay, let's try a few of these. So I have sine of 105. So we don't really know sine of 105 just offhand, right? And we don't really have any two things we can add together probably to get it, like doing a sum one. So we need to do doubling it and dividing by 2. So we're going to do the half angle formula. So this is the same thing as writing it as 210 divided by 2. That's still 105. And I'm just going to use the formula for sine, half angle. So I have plus or minus, and it's always the minus 1. And I plug in 1 minus cosine of 210, because we do know that angle, all divided by 2, and we evaluate it. So I have plus or minus the square root of, so the cosine of 210 you can do off to the side. 210 is right here. So what's the cosine? Yep, negative root 3 over 2. Whoops, I gotta have a double negative there. All over 2. So I have minus from the formula plus the negative inside. And then we need common denominators in the numerator. So I would multiply this, I would just make this 2 over 2, right? Since it's 1. So I've got 2. I have a negative times a negative here, so I'm going to do plus square root of 3 all over 2. That's this denominator here. I still have divided by 2. So then we got to flip and multiply. So you guys, this is really like a 2 over a 1. So I need to flip and multiply to get it out of the denominator. So now I have plus or minus the square root of 2 plus the square root of 3 over 4. And my last step is, second to last step, I can go ahead and take the square root of 4, which is 2. Okay, then I need to decide if my answer is positive or negative. It's always based on the angle you started with right here, which was 105. The sine of 105. Where is 105? Well, this is 0, this is 90, this is 180. Yeah, it's in the second quadrant right here. So we're talking about the sine. Is the sine here positive or negative? Positive, because the y value is up right here, so the sine is positive. So I'm going to, at the very end, put a plus sign, or nothing, because that means positive. Okay? All right, let's do tangent of 195. I need some space. Oh yeah, it is supposed to be changed to 195. So 195, we're going to use a half angle formula because that's what it says to do. So first you double it. So I can write it as 390 over 2. So if you times that by 2, it's the same as 390 divided by 2. And we just plug into the formula that we just wrote down plus or minus. Are you guys good with me just plugging it in instead of rewriting the formula? Okay. 1 minus cosine of 390. What? Yes. I'm going to do that on the next step, but yeah. Okay. So I just plugged it into the formula. And then you're like, 390, that's kind of a pain. So you guys, 390 is the same as, if you just subtract 360, it's the same as 30 degrees. So now I got to evaluate the cosine of 30 degrees. So I go back over here to my good old unit circle. What is the cosine of 30 degrees? Yep, positive root 3 over 2. So I have 1 minus the square root of 3 over 2. And I have 1 plus the square root of 3 over 2. Then we've got some awesome fractions here. So I would change 1 to 2 over 2 right here. And if you change this to 2 over 2, you get 2 minus the square root of 3 all over 2 for the numerator. And in the bottom, you got to change this guy to 2 over 2. So you have 2 plus the square root of 3 over 2. Okay, what cancels right there? Yeah, these 2's cancel. You can multiply by root 2 over root 2 because they're technically root 2's. So then I've got plus or minus the square root of 2 minus the square root of 3 over 2 plus the square root of 3. That's as simplified as it gets, but we do need to go back to our original angle and decide if the tangent is positive or negative. So I go back, and my original angle here is 195. So again, it goes 0, 90, 180. So 195 is like somewhere around here. So it's negative, negative. So is the tangent positive or negative? It is positive. So at the very end, if you want to just erase your plus minus, because it is positive, that's probably what I would do. Okay. We have more. Okay. So it's really important you know how to draw your triangles. There's a lot of these on the homework. So draw yourself 2 little grids somewhere, if you have room somewhere on your paper. Yeah. This note should have been like 2 pages long. You guys really had to squeeze that in. Okay. So we'll call this one alpha, and we'll call this one over here beta. So it's 2 separate triangles that we're drawing. This one says sine alpha is negative 4/5. So that means sine's negative. So if sine is negative, we're down here where the y is negative. And then it also says negative pi over 2 is less than alpha is less than 0. So negative pi over 2 is down here, and 0 is here. That means I'm in between those two. So this even tells us what quadrant, even without the first part. So go ahead and draw your triangle right in the middle there and connect it to the x-axis. So then it tells us that sine is negative 4/5. That's always opposite over hypotenuse. So sine of this angle is opposite. So this guy is negative 4 over hypotenuse, which is 5. So that means this side is positive 3. Okay, now we got to draw beta. So this says cosine beta is negative 5/13. So cosine's negative here and here. But then it says that sine is positive. Sine is positive up here. So we're going to do this triangle and connect it to the x-axis. Okay, cosine is adjacent over hypotenuse. So adjacent is right here. That's negative 5. And hypotenuse is right here. You guys got this triangle memorized? 12. Good. Would be that side right there. Once you draw your triangles, it's plugging in the formulas and plugging in the fractions. So first of all, we have our cosine alpha plus beta. So this one, you guys know this formula. It goes cosine minus sine. I'm going to run out of room here. And now we just plug in the fractions. So what is the cosine of alpha? So I come over here to alpha. Cosine is adjacent over hypotenuse. So I plug in 3/5. And then I come over here to beta, because now it's saying what's the cosine of beta? Beta's cosine is adjacent over hypotenuse is negative 5/13. Then I have a minus sign from the formula. Now I come over here and I do sine of alpha. What is the sine of alpha, you guys? Negative 4/5, opposite over hypotenuse. And then I come over here because it's talking about beta. What's the sine of beta? Yeah, 12/13. And then you guys can like evaluate that, and you should get 33/65. I'm not going to take the time to do all those fractions. Okay. For 7, you guys, I just will quickly show you, this is the formula for the double angle for sine, which is 2 sine beta cosine beta. Be sure you use the beta that's in here. And then you plug in the fractions, right? So I'm like, oh, what's the sine of beta? So I come over here and it is 12/13. What's the cosine of beta? It's negative 5/13. And you evaluate it, and you get negative 120 over 169. Okay. And this last one, we would plug in the formula. Anyone happen to memorize this while you were sitting here? Plus or minus, you got it. Yeah, close your eyes and think about it. Cosine beta for this one, divided by 2. All right, good. All right, so we've got plus or minus square root of 1 plus. So now I need cosine beta. So again, you go back up here to your chart. Cosine beta is negative 5/13 all over 2. All right, I assume that you guys can like simplify that a whole bunch. It's a pain. Do you guys want me to go through how to do all that? No. There's one really important thing though, so it does simplify to this in the end. And the important thing is the positive negative. This part's kind of hard. So we got to think through this. So you actually go up here to beta, and beta is always from the positive x-axis over. This is actually the angle beta. This is the reference angle beta inside. So if I take half of this angle, what quadrant would I be in? Just by like eyeballing it. The first one. You take half of this and you're like here-ish, right? You're in quadrant 1. So that's half of beta. Well, if it's in quadrant 1 and we're talking about cosine, cosine is going to the right. That's positive. So that means that this guy is going to be positive. So you have to take half from that picture. That's kind of a pain. Okay? I know.